Hello everyone, welcome to today's class. Today we will discuss about how to solve two-port network parameters for a given network. Okay, so let us consider a two-port network. Okay, let us consider this two-port network. So let us solve the two-port network parameters one by one. So first, let us find the Z parameters for this two-port network. So to find the Z parameters, first we need to write the parameter equations. What is the Z parameter equations are? V1, V2 are dependent variables, I1, I2 are independent variables. So we will write V1 is Z11 I1 plus Z12 I2, Z21 I1 plus Z22 I2. Okay, these are the Z parameter equations. So if you write the individual parameter equations, here Z11 is nothing but V1 by I1 with I2 0. Similarly, Z21. Z21 is V2 by I1 with I2 0. And Z12 is V1 by I2 with I1 0. Z22 is nothing but Z22 is V2 by I2 with I1 0. So now let us apply the condition I2 0 to find the parameters Z11 and Z21. So in this circuit, if you apply I2 0, I2 0 means this output port is already open circuited. So if you open circuit this one, if any source V2 that is connected, that will be disconnected. For example, here is an element or the source V2 is present. This V2, let us consider 10 or 20 volts. Source is connected. So to make this I2 0, we need to open circuit these terminals. If the source is connected, we need to disconnect these terminals. So source is disconnected here at the port 2. Okay, if you name this as port 11 dash 22 dash. Okay, then if you open circuit this, okay, if you redraw the circuit once again, we'll get the simple circuit to find the Z parameters Z11 and Z21. This is the circuit diagram. The input voltage source, this I1, 1 ohm, 2 ohms, 2 ohms again. This is 4 ohms resistor. 4 ohms resistor. Now I2 0, so this node voltage becomes V2. Now for this circuit, we need to determine these ratios V1 by I1. V1 by I1, we know that the input impedance. So if you find the input impedance or R equivalent at the input is nothing but the 4 ohms and 2 ohms are in series. So 6 ohms parallel with 6 ohms parallel with 2 ohms. So that equivalent is 6 into 2 divided by 8. So this is 3 by 2. 3 by 2. This 3 by 2 equivalent and 1 ohm are in series. So finally, what is R equivalent is 1 plus 3 by 2. So this is 5 by 2 ohms. 5 by 2 ohms. Or we can write 2.5 ohms. 2.5 ohms is the input impedance, the R equivalent. So here in this case, we have already applied I to 0. So this R equivalent is nothing but Z11. Z11 equal to 2.5 ohms. Similarly, to find Z21, we need the relation between this V2 and I1. So we know we already have the relation between V1 by I1. This is Z11 is nothing but V1 by I1. So we have the relation between V1 and I1. V1 and I1. So here if you apply current division principle, we get the relation between V2 and I1. Let us see how it is means. So here in this element, I1 is entering current. So 1 ohm is in the same path. So current is same. So at this node, entering current is I1. Entering current is I1. So current will be divided in these branches. Let us name this as IB and this is IA. So this is IB. This current is flowing like this. This is IB. So what is V2? V2 can be expressed as 4IB. Why? Because in this branch that is connected to ground, so this node voltage is V2. V2 can be expressed as current that is flowing through 4 ohms resistor is IB. So V2 is 4IB. 4IB. Now apply current division principle so that we can express IB in terms of I1. So IB is nothing but I1 into opposite resistance is this one. 2 ohms divided by 2 plus 2 plus 4. That is equal to I1 into 2 by 8. So this value is I1 by 4. I1 by 4. So IB is I1 by 4. If you write 4IB, 4IB is 4 into I1 by 4. So this is I1 only. This is I1. Now, if you write Z21, Z21 is V2 by I1. Here we have obtained V2 is equal to I1. Magnitude wise, this V2 is equal to I1. I1 is multiplied with some 1 ohm resistance. So V2 is equal to I1. So V2 by I1 is 1 ohm. V2 by I1 is 1 ohm. Okay, this is how we can find the Z parameters Z11 and Z21. Similarly, to find the Z parameters Z12 and Z22, we need to apply I1 as 0. So to find Z12 and Z22, put I1 0. In this circuit, if you make I1 as 0, so this will be open circuited. This will be open circuited. 1 ohm resistor. This is 2 ohm resistor. This is also 2 ohm resistor. This is 4 ohm resistor. This V2. This I2. This is 2 ohms, 2 ohms, and 4 ohms. Okay. So here we made this I1 as 0. there is no current flows through this 1 ohm resistor means this node voltage is V1. There is no potential drop across 1 ohm resistor. Why? Because there is no current flow. So this also becomes V1. Okay. Now, if you find the equivalent resistance here, R equivalent at the output, what is R equivalent at output? Is nothing but this is open circuited, so there is no current flow. These 2 ohms and 2 ohms are connected in series. So 4 ohms parallel with 4 ohms. 4 parallel with 4, that is 4 by 2. Or if you write in detail, so this is 2 ohms. So what is Z22? Z22 is nothing but V2 by I2 with I1 0. Already we have applied the condition I1 equal to 0. So Z22 is 2 ohms, V2 by I2. Similarly, Z12 is V1 by I2. We already have the relation of V2 by I2 is 2 ohms. That implies V2 is 2I2. V2 is 2I2. So V1, if you express in terms of I2, so that we can find this ratio V1 by I2. So here also the entering current is I2. So let us apply current division principle. This Ix and this is Iy. So what is Ix? In terms of Ix, we can express V1 is 2Ix. So here the flowing current is Ix. This current is Ix. So V1 is 2Ix. Now what is Ix? Apply current division so that Ix can be expressed in terms of I2. So Ix is nothing but entering current is I2. Opposite resistance is 4 ohms. Divide by 2 plus 2 plus 4. So that is I2 by 2. So Ix is I2 by 2. Now what is V1? V1 is 2Ix. 2 into I2 by 2. So this is I2. Now what is V1 by I2? Here V1 is equal to I2. So V1 by I2 is 1 ohm. So we have determined the Z parameters as Z11, Z12, Z22. Sorry. This is Z21. Z21. This is Z22. It's equal to, we have obtained Z11 as 2.5. This is 2.5 ohms. Z12 and Z21 are 1 ohm. Z22 is 2 ohms. Z22 is 2 ohms. Units are ohms. Okay, this is how we can measure the Z parameters for the given two-port network. Now let us find the Y parameters for the given two-port network. The same network, let us consider once again, draw this circuit. So 1 ohm resistor, 2 ohm resistor, 2 ohms, 4 ohm resistor. This I2, this V2, this I1. This node voltage is V1. So this is 1 ohm resistor, 2 ohm resistor, 2 ohm resistor, this 4 ohm resistor. So to find Y parameters, first we need to write the parameter equations. So I1, I2 are dependent variables. This Y11, V1 plus Y12, V2, Y21, V1 plus Y22, V2. Okay. So if you write the individual parameters, Y11 is I1 by V1 with V2 0, Y21 is I2 by V1 with V2 0. So Y12 is I1 by V2 with V1 0, Y22 is I2 by V2 with V1 0. So to find any two parameters, we need to apply the same condition V2 0. Or to find Y12 and Y22, we'll apply the condition V1 equal to 0 in the given two-port network. So first, to find Y11 and Y21, to find Y11 and Y21, put V2 0, put V2 0. If you substitute V2 as 0, these two terminals are short circuited. V2 always voltage source 0 means we need to replace with its internal resistance. Let us consider this V2 is ideal voltage source, so that this will be short circuited. Now, if you find the variables V1, I1 and I2, okay, in terms of the parameters or the ratio. So Y11 is nothing but I1 by V1. Already we have substituted the condition V2 equal to 0. So I'm not repeating again. I1 by V1 is nothing but 1 by this R equivalent. 1 by R equivalent. This 4 ohm resistor is in parallel with short circuit path. So 4 into 0 by 4 plus 0. Any resistor that is connected in parallel to the short circuit path, that can be 0. So now if you observe this 2 ohms is connected directly to ground. So 2 ohms and 2 ohms are in parallel, and this parallel combination is in series with 1 ohm resistor. So equivalent resistance, R equivalent is nothing but 1 plus 1 ohm. 2 ohms parallel combination is 1. So this combination is in series with 1 ohm resistor. So R equivalent is 2 ohms. I1 by V1 is nothing but 1 by V1 by I1, or 1 by R equivalent. R equivalent is 2. 1 by 2. So this can be written as 0.5 mho. Units are mho for admittance parameters. Similarly, Y21 is the ratio of I2 by V1. I2 by V1. With the V2 0, we already substituted. So I2, what is this current I2 is, if you express in terms of V1. This I1 is entering at this node. So this is IB and IA. Name it as IB and IA. At a node, current will be divided. So what is IB from this circuit is IB is, these are two equal resistors. So current will be divided equally. So this is I1 by 2. I1 by 2 is equal to minus I2, flowing in opposite direction. IB is flowing in opposite direction to this I2. So this is minus I2. Now we know the relation between V1 and I1. V1 and I1 is, this is V1 by I1. So this implies V1 equal to 2I1. V1 equal to 2I1. So I2 by V1. I2 by V1. So we have the relation. If we express I2 in terms of I1, I2 in terms of I1, so I2 is nothing but minus I1 by 2. I2 is minus I1 by 2. This is I2. I2 is minus I1 by 2 divided by V1 in terms of I1 is 2I1. This is 2I1. So this I1 and I1 gets cancelled. This becomes minus 1 by 4. So this is minus 0.25 mho. Minus 0.25 mho. To find the other parameters, we need to substitute here to find y12 and y22. Y12 and y22 put V1 as 0. V1 as 0. So if you redraw this circuit, this V1 becomes 0. So this becomes short circuited. This is 1 ohm resistor. This current is I1. This 1 ohm resistor. This 2 ohms is connected as it is 2 ohms. And this is 2 ohms. This is 4 ohm resistor. This is the circuit after substituting the condition V1 equal to 0. This I2, this is V2. So now if you consider Y12, Y12 is I1 by V2. I1 by V2. Y22 is nothing but the output admittance, short circuit output admittance. So if you find equivalent resistance here, 1 by R equivalent becomes Y22. If you consider this circuit, 1 ohm and 2 ohm are in parallel, 1 into 2 by 1 plus 2, that is 2 by 3. 2 by 3 is in series with 2 ohm resistor. 2 by 3 is in series with 2 by 2 ohm resistor. So this LCM is nothing but 8 by 3. This 8 by 3 parallel with 4 ohm resistor. 8 by 3 into 4 divided by 8 by 3 plus 4. So this is 8 into 4, that is 32 divided by 12 plus 8, 20. Okay. So this is 8 times, 5 times. This is 8 by 5. 8 by 5 ohms is the R equivalent. 8 by 5 is the R equivalent. So what is Y22 is I2 by V2. This is 1 by R equivalent. This is 1 by R equivalent. So this is 5 by 8. 5 by 8 is 5 by 8 mho, or 0.6, 0.6 to 0.62. 0.62 by 5 divided by 8. So this is 6 times 48, 20, 40, 0.625. 0.625 mho. Now we have the relation between I2 and V2. That is, V2 can be expressed as 8 by 5 I2. 8 by 5 I2. Now, if you find this unknown node voltage, this is V1. V1 is 0. V1 is 0. Let us consider this is Vx. This is Vx. If you write unknown node equation, so that we can have the relation between this V2 and I1. So series 1. So if you write the node equation, Vx by 1, Vx by 1, that is leaving current, Vx by 2, another leaving current, plus Vx minus V2. This node voltage is V2. So Vx minus 2 divided by 2. This is one leaving current, this is leaving current, this is leaving current. So all the currents are leaving from this node. So this is equal to 0. So if you consider Vx by 1, Vx by 2 plus Vx by 2. So this is 2Vx is equal to V2 by 2. So Vx is nothing but V2 by 4. Vx is V2 by 4. Now what is the relation between this I1 and Vx? I1 and Vx is, I1 is the current which is flowing in this direction. But we have already seen Vx by 1 is the current which is flowing in this direction, leaving current from this node. So this I1 is nothing but minus Vx by 1, minus Vx by 1. So this is I1 is minus Vx. So what is Vx? We know in terms of V2, that is V2 by 4. Okay, now the desired ratio is I1 by V2, I1 by V2. So I1 divided by V2 is minus 1 by 4, minus 0.25 mho, minus 0.25 mho. So we have obtained all the Y parameters. We have obtained all the Y parameters as Y11, Y12, Y21, Y22. It's equal to, this is 0.5, Y11 is 0.5, Y11 is 0.5, Y12 is minus 0.25, it's also minus 0.25, Y22 is 0.625, units are mho. Units are mho. Okay, so these are the Y parameters for the given two-port network. For this same circuit, we can find the other parameters, ABCD and H parameters. Okay, we'll continue in the next class. Thank you for watching.